Good day everyone, we are group 2 and we are going to discuss about circle graph. So what is a circle graph? A circle graph, or commonly known as a pie graph, it is a statistical chart style designed to illustrate numerical proportion datasets. Its circular shape is divided into sectors, with each sector representing a percentage of the total. These sectors are typically labeled and color-coded for easy interpretation. The beauty of the pie graph lies in its direct visual, like the size of each sector accurately reflects the quantity it represents, facilitating quick understanding of relative proportions within the dataset. This simplicity makes circle graph a popular choice for conveying complex information clearly across various sectors, such as business, economics, and education. And also, a circle consists of 360 degrees, making it a complete shape. This 360-degree structure allows for easy division into smaller sections, commonly referred to as arcs. So each arc represents an edge of the circle and is named based on its corresponding angle. These arcs also serve as a specific purpose, like to visually represent the percentage of the population that is selected a particular answer or category.
In the history of pie charts, William Playfair, a Scottish businessman, engineer, and economics writer, created the first known pie chart in 1801. His work featured two such graphs in the Statistical Breviary of 1801. Playfair's initial use of the pie chart was to compare geopolitical territories represented by circles, sometimes segmented into slices. In 1858, Charles Joseph Minard, a French civil engineer, used a circle-divided map to display the proportions and amounts of meat supplied to the market. During the Crimean War, Florence Nightingale used statistics to draw attention to the mortality rate caused by poor sanitary conditions. Nightingale adapted the pie chart to make it more readable. Instead of varying the width of the wedges, she made their length variable, creating a graph that resembled a cock's comb.
A pie graph is a circular chart which is divided into sectors in which the area of each sector represents the size of the data. It is also known as a circle graph. Remember that there are 360 degrees in a circle, so each group in the pie chart will be a proportion of the 360 degrees. So, to elaborate on the first explanation, a pie chart is typically represented by a circular shape, which symbolizes the entirety of the data being represented. The circle represents the whole, with each sector within the circle representing a specific category or subset of the data. Since the circle has a 360 degrees, the pie chart encompasses the total degree measure. Each sector's angle is calculated based on its proportionate size relative to the total data. It includes labels or legends to provide additional information about each sector, such as the category name or the exact percentage it represents. These annotations help viewers interpret the chart more accurately. Now, on to the second explanation. So, a pie chart displays data, information, and statistics in an easy-to-read pie slice format with varying sizes, telling you how much of one data element exists. The bigger the slice, the more of that data was gathered. So, instead of representing data in a tabular or numerical format, a pie chart utilizes visual elements to convey information. The circular shape of the chart resembles a pie, hence the name, pie graph, with each slice resembling a piece of that pie. So the size of each slice in the pie graph indicates the relative magnitude or significance of the corresponding data category. Larger slices represent categories with higher values or percentages within the data set, with smaller slices representing categories with lower values or percentages. So, one of the key benefits of a pie chart is its simplicity and ease of understanding. The visual depiction of data as pie slices makes it accessible to a wide range of audiences, including those without extensive statistical or mathematical knowledge. Lastly, various applications of pie charts can be found in business, school, and at home. For instance, in business, pie charts can be used to show the success or failure of certain products or services. They can also be used to show market reach of a business compared to similar businesses. At school, pie chart applications include showing how much time is allocated to each subject. It can also be used to show the number of girls to boys in various classes. You can also use pie chart as to how much money you spend in different areas. Lastly, at home, pie charts can be used when figuring out your diet. There are many applications of pie charts, and all are designed to help you to easily grasp a bunch of information visually.
Let's move on to the usage of the circle or the pie graph. Pie graph is used to show the data in proportion, and it is used to display the contribution of each value or slice to the total or the pie. The 2D pie is used to show the proportions of a whole. It is used when numbers are equal to 100%. The chart contains only a few pie slices because many slices makes the angle more harder to estimate.
Now for the definition of terms. Data. Data refers to factual information or digital information. Dataset. Dataset is a collection of data that is organized and structured. Decluttering. Decluttering is synonymous to organizing. Demographics. Demographics are statistics that describe populations and their characteristics. Totality. Totality refers to the total amount. Value. Value refers to the numerical worth. Yield. Yield refers to the result.
The steps and procedures in making a circle graph. Now, the first step is to collect data. This step allows us to know what values we are working with and how we will apply it to the graph. Now, the easiest way to do this is through surveys. The second step is to find the totality or the total population. This helps us determine what the value of 100% is in certain circumstances. And to do this, we can find the totality by adding all the surveys or the results in the survey or the data collected. Now, the third step is to convert portion values to percentage. So with the totality from number 2, we divide the result of the survey to the total population before multiplying it with 100 to convert the value into percentage. This is so that the collected data from number 1 is easily absorbable by the audience who will be looking at our circle graph. Now, the fourth step is to find a degree for each portion. So with the expression of the portion values percentage, multiply it with 360 degrees to determine the degree of each portion. Now, 360 degrees is the total angle of our circle, and the degree of each portion represents how much space each value in our survey will take up in the circle. So the fifth step is to draw the graph. Now, this only applies if we are doing it by hand, but nowadays we mostly do this digitally. So first we draw the whole circle and then determine the center or the focus of the circle. Then split the circle graph into the portions based on the degrees determined in step 4. Now, the last step is to assign names, percentages, and make a legend. Now, the usage of names helps to not mix values with others. This is done by naming and writing the corresponding percentages of each portion based on what value was used. And then making a legend can help with decluttering names by using color coding. Now this last step is all for the sake of organization so that the circle graph is easily absorbable and so that it can easily be viewed by other people and understood.
Sample problem number 1. A hospital conducted a survey to determine the distribution of patients' demographics. The survey collected data from 200 patients regarding their age groups. The result as are follows. Age 0 to 20, 50 patients. Age 21 to 40, 70 patients. Age 41 to 60, 60 patients. Age 61 and above, 20 patients. Sample problem number 2. In a hospital ward, there are 50 patients and their diagnoses are categorized into 3 types: respiratory infections, musculoskeletal injuries, and gastrointestinal disorders. The data on the patient diagnoses are as follows: respiratory infections, 20 patients; musculoskeletal injuries, 15 patients; gastrointestinal disorders, 15 patients.
First problem. First of the step, collect the data in the sample. Problem to know what value we are looking for. Suppose 0 to 20 age overall 50 patients, 31 to 40 age overall to 70 patients, and the age of 41 to 60 overall 60 patients, as well as the last age 61 and above the total of 20 patients. Next, find the totality and calculate the age of the patients. To do this, divide the number of patients in each age by the total number of patients, which is 200. 200 patients regarding of the age group. Age of 0 to 20, 50 quotient of 200 equals 0.25. The age of 21 to 40, 70 quotient of 200 equals to 0.35. The age of 41 to 60, 60 quotient of 200 equals 0.3. And age of 61 and above, 20 quotient of 200 equals 0.1. After this, convert the portion value into percent. Age of 0 to 20, 0.25 multiplied by 100 equals 25%. Age of 21 to 40, 0.35 multiplied by 100% equals 35%. Age of 41 to 60, 0.30 multiplied by 100% equals 30%. Age of 61 and above, 0.1 multiplied by 100% equals 10%. Let's draw the pie graph and use different colors to identify it. As can you see in the pie graph, the age of 0 to 20 is 25%, and the age of 21 and 40 is 35%, and the age of 41 to 60 is 30%, and the age of 61 and above is 10%. Second problem. First of all, we collect the data in the sample problem to know what value we are looking for. Suppose respiratory infections, 20 patients; musculoskeletal injuries, 15 patients; gastrointestinal disorders, 15 patients. Next, find the totality and calculate the percentage of each patient's diagnosis. To do this, divide the number of patients in each by the total number of patients, 50. 50 patients in hospital, respiratory infection, 20 quotient of 50, 0.4. Musculoskeletal injuries, 15 quotient of 50, equals 0.3. Gastrointestinal disorders, 50 quotient of 50, 0.3. After this, convert the portion values into percent. Respiratory infections, 0.4 multiplied by 100% equals 40%. Musculoskeletal injuries, 0.3 multiplied by 100% equals 30%. Gastrointestinal disorders, 0.3 multiplied by 100% equals 30%. Next, find the degrees for each portion. As a given result, the respiratory infections is 40%, the musculoskeletal injuries is 30%, and the last, the gastrointestinal disorders is 30%. Now, Let's draw the pie graph and use different colors to identify it. As can you see in the pie graph, the respiratory injuries is 40%, the musculoskeletal injuries is 30%, and lastly, the gastrointestinal disorders is 30%.
Based on the first sample problem, the provided data we have are age 0 to 20, 50 patients, age 21 to 40, 70 patients, age 41 to 60, 60 patients, and age 61 and above are 20 patients. The pie chart illustrates the distribution of patients across different age groups, with the age 0 to 20 category represented by blue and occupying 25% of the circle. The age 21 to 40 category represented by orange and occupying 35%. The age 41 to 60 category represented by gray and occupying 30%, and the age 61 and above category represented by yellow and occupying 10%. Therefore, the chart provides a visual representation of the proportion of patients in each age group. Sample problem number 2. Based on the given data, respiratory infections are 40%, musculoskeletal injuries are 30%, gastrointestinal disorders are 30%. We'll use this percentage to represent the portions of the graph. So the pie graph visually represents the distribution of patient diagnosis in the hospital. The largest portion of the pie, occupying 40%, represents respiratory infections, indicating that this condition is the most prevalent among the patients surveyed. Following closely, both musculoskeletal injuries and gastrointestinal disorders each account for 30% of the pie, suggesting they are equally common diagnoses among the patients. Overall, the pie graph provides a clear visualization for the distribution of the patient diagnosis, with respiratory infections as being the most prevalent, followed by musculoskeletal and gastrointestinal disorders, which are equally represented.
In conclusion, a pie chart, also known as a circle graph, was created by William Playfair in 1801, depicting the proportions of the Turkish Empire. A pie chart is a circular chart divided into sectors to represent numerical proportion datasets. These graphs enables a quick and easy understanding of relative proportions within a dataset by dividing a circle into sectors that represents different percentages of the total. The 360 degrees nature of a circle allows for accurate representation of data based on specific angles, making it an effective method for displaying complex information in a range of fields.
Pie charts can find applications in various fields like business, education, and personal use. Steps to create a pie chart include collecting data, converting portion values to percentage, finding degrees for each portion, drawing the graph, and labeling with names and percentage. Sample problems demonstrate practical use, such as analyzing patient demographics or customer preferences. And that ends our presentation of a pie graph. This was Group 2. Thank you very much.